Okay, before I go on to the calculation I mentioned at the end of the last video, I digress. I did ask what would be the average value if the curve looked like this instead of a straight line. And let's say, not for this exact situation, not for any of these situations. Let's just say that this is 50 of something and this is 10 of something. Okay? Now, is the average value for this curve here greater or less than 50 divided by 10 or 5? Okay? And some people want to say it was greater because the average value would occur further along the curve or something of that nature. Well, let's think about it. Remember, just reinforcing the idea of what an integral is. If you multiply the average value of this thing by the interval, you get the area, something that represents the area under the curve, or something's represented by the area under the curve. Is the area under this curve more or less than half of this total area? Well, clearly, it's less than half. It's less than the area would be if the line was straight, which means that since the area is equal to the average value multiplied by the length of the interval, by the length 10, that the average value here has to be less than 5. Less than it would be if you had the straight line. Another way of looking at it is this curve is always below this curve. The average value of the function represented by the green line is, well, the area under that is half the area of this big rectangle, which is half of 500 or 250. And then if you divide that area by 10, you get 25. So the average value of the function represented by this straight line is 25. Now this curve is always lower than the straight line, so all the values are less than they are in the straight line, except at the very first and very last points. Clearly, the average value here is going to have to be less than the average value for the straight line. The average value for the curve has to be less than the value for the straight line. Now it's not all that much less because, of course, the area here under the curve is bigger than the area of this little section. So the area is closer to the area under the straight line graph than it is to say half that area. But you might estimate the area is probably somewhere in the 35 to 40 range. Okay. Then I said that wrong. Area is probably the area under this is 250, so the area under this curve is maybe around 200. So anyhow, you want to think about that. You really have to understand how average value can be estimated, how the average value multiplied by the interval gives you the area, and how that's related to the integral.